Okay, good morning, everyone. Good evening to those of us who are in the Eastern time zones. I'm going to go ahead and get started. It's a little bit past 6. Okay, yeah. Welcome back to CS 199, even more practice. Today's topics, we're going to review a little bit, going over this keyword from last week or yesterday, I think. We're going to go over static methods and static fields. And then we're going to look at a new topic, inheritance. So inheritance is the lesson for today in 125. So I will try to get you acquainted with that before we really move on to the practice problems. Yeah, and then as always, remember that you can follow along on the class website. And the slides are on the CS 199 website right here. Okay, so first topic, this keyword. So this is kind of that special Java keyword that we talked about. And it just references the current instance of an object in a class. So in this example right here for the dog class, we have this referring to the name of one particular instance of the dog class. And then we can assign a new name to that particular instance. And that's what this is doing in this example. So you won't see us really allowing you to do this where you have an instance field like name, and then you refer to it with this, and then you reset the value of name with another variable called name. It's really not good practice to do that. It's difficult to read if you have two things that are called name and you're resetting both of them. So our checkstyle will give you an error if you try this on the class website at least. But in theory, this is something you could do in Java. You will also see this keyword used for constructor overloading. So I think there's an example of that maybe. No, there is an example of that. But I think there was an example in the class where if you use this keyword, you can overload one constructor with another constructor by calling the other constructor within one constructor. And you'll see that we'll have to use that in one of the practice problems that are coming up. So really quickly pull up that example from class so that you guys just have an idea of what that looks like. Yeah. Right, so you can use this keyword here in this example. We have two constructors for the course class, and you're using this keyword to overload one of the constructors and access this constructor. So those are the two primary use cases over this keyword. You'll see it quite often in the MP. Yeah, so here is your first practice problem. There's no starter code for this one. Kind of just letting you guys get creative with it if you need to. So there's two classes, or just one class actually, one class that you need to create called country. Inside of country, there should be 3 instance variables, name, national bird, and population size. Just make sure you create a constructor for country that uses this keyword to set up all 3 instance variables. But like I said, you can't do it like this. Checkset will give you an error, so make sure you call your instance variable something else where they're different in the assignment. And then the second part of it is to create a constructor for country that takes in a national bird and a name, but not a population size, and then use this keyword to call the first constructor by setting the value of population size to 100. So pretty straightforward, very easy. We'll do 10 minutes for that one. And if you have any questions, let me know. So we'll regroup at 6:30. 6:18. And let me know in the chat when you guys finish the problem so we can review it as soon as you're done. Okay, it looks like everyone's done. Done but shows hides a field. Yeah, so you get that check style error that says shows hides a field when you're trying to do this assignment where the instance variable name and the variable name of the argument that you passed in are the same. So if you just make it a different variable name. Let's review solution. So public class country, string name, string national birth, int population size. Okay, and then public country, string name, string, oh. Yeah, so if you do like string name and then we did the string national birth and int population size. And then you try to set them all like this dot name equals name, whoops, and it's not national bird, and this dot population size equals population size. So if you try to do this, the problem is that it will give you a check style. Hides the field, hides the field, hides the field. So you have to do it like this. You have to call it something else. You have to call the argument something else so that we don't get this checked out anymore. Okay. Right. So the second part of the question was overloading the constructor using this. This is pretty straightforward, I think. Upload country. And then just do strings, national, bird, and string set name. Okay, and then you can call this constructor up here by just going this dot not this dot set name set national bird and 100. Yeah. Okay, so that's what this looks like. Make sure that when you're calling this constructor that you pass in the arguments in the same order that they're expected up here. So, any questions on that? If not, I'm going to move on to the next section. Okay. So next topic, static methods and static fields. I think this was also part of yesterday's class. Yes. Yeah. Okay, so we use a static keyword for a method anytime you want to ensure that the method is attached to the class and not the instance of the method. And what I mean by that is like it's not really impacted by the instance in any way, and you can't access any of the instance variables for the class when you're using a static keyword. And then you have static fields, which you typically use them with the word final, the keyword final, to create kind of like symbolic constants for your class. Like you might want to be like, you might want to have a constant for the speed of light, for example, if you were doing something related to the solar system. And then you could use the public static fields to declare that as a constant along with the keyword final, and that would not change very much. So static methods, oh, I realize that there's a typo here. Static methods are for instance related methods, anything, no, sorry, not instance, class related methods. Static fields are typically used when you want to have constants inside of your class, or even outside of your class, I guess. If you want to use them outside of the class somewhere. So here's an example of how we use static methods. So we have a class called building. It's got these two instance variables. It's got a constructor. It's got getName. Okay. And then we're creating an instance of the building called Cbool. And then we're trying to print out whether what cbool.getName is. Okay. But let's take a look at the getName method. The getName method has the static variable here, not variable, static keyword here. So that means that it can't access any of the instance variables like name or height. So it's this method is by default unable to access name unless you pass in name or something like that. So that's what that means. So this line of code will not work. It'll just give you an error. I guess I can try to paste it in to show you what that is. Yeah, so it's telling you here non-static variable cannot be referenced from a static context. So non-static variable is name, static context is getName. So it's just telling you that you need to take out the static if you want to use that. So here is some practice on the static methods and static fields. You're going to be creating a class called dog. Dog should have a name and an age. Dog should come with a constructor for name and age, and then you should use the this keyword for that. And then you're going to create a method called method A that returns a string called this is the dog class. Then you're going to create a method called method B that returns a string that says this dog's name is whatever the dog's name is, and that's just what's going to show up where these curling braces are. And then once you're done with that, try to figure out which one of these two methods requires the static keyword and try to use it correctly, and then call the method and print out what is returned by the method. So a lot going on here. And in the chat, if you can put in which one of the two methods is the static method when you're done, that will let me know that you guys are done. Yeah, so 10 minutes for this one. We'll regroup at 6:34. Couple more minutes, guys. Just let me know once you finish. Okay, so looks like everyone's done. Do some review. Okay. So I think Andrew sent me his code. And I think it looks good. So I'm just gonna paste it in here. I hope you don't mind, Andrew, and we'll just walk through it. Okay, so you have the dog class, and he set up 2 instance variables. He set up a constructor for the dog class using this, so that looks good. And then he's got 2 methods, method A and method B. And let's just double check that this works. Let's write some tests in, or just to make sure the constructors are working okay. Okay, so in line 2, legal sort of expression. Why would it say that? Oh, okay. Um, I have no idea what this means. Let me think about this for a second. Public static string, method A, and public string method B. Oh yeah, so here you want to so you don't want to pass in anything for set name. You can just access name directly, like this, and that should allow you to access the name. And then for this one, method A, this looks correct to me. And this looks correct to me. I have no idea what this error means. Legal start of expression. Okay. Yeah, it does. In the solution, it does declare the name and the age as instances in the beginning. But that's what you're doing here also. So why is it giving you an error? I don't know. Hmm. Yeah, I mean, the only difference between the solution and your code though seems to be the private modifier, but that shouldn't make a difference. Okay, guys, let's again, let's see what the legal start of expression means. Are we missing a semicolon anywhere? Doesn't look like it. Um, Okay, let me try pasting in the solution code to see if it comes with any errors. Huh. That was so weird. I don't see anything wrong with it. So why is it doing that? Oh, okay. I'll keep debugging this while you guys are working on your problems. Seems to be kind of odd. Yeah. All of a sudden we're getting all these errors in here. Okay, we'll come back to that. Let's keep going with inheritance. Okay, so today's lesson is on inheritance, and at this point you guys have learned about a lot of things in classes. You've learned about encapsulation, you learned about like what classes are, instances, static methods, this keyword. So we're just going to keep building on what you've learned and kind of take it to the next step. And the next step is inheritance. So inheritance is basically you have one class and you can extend the behavior of that class into another class. For example, you could have a computer class. And when I say computer class, I mean classes in like Java class. And then you might have a Apple computer class or a Dell computer class or a HP computer class. So you could have those three kinds of classes, and the computer class would be kind of the parent class, and the Apple class or the Apple computer class and the Dell computer class, they would be kind of the children class because they have all of the properties of a computer in general, but they'll have their own properties as well. Like Apple computers have their own set of properties, and Dell computers have their own set of properties. So there's this idea of a child class inheriting properties from a parent class or extending it. So extends is the keyword that we will use to create this kind of one-way relationship between two classes. As in the child class extends the parent class. The Apple computer class extends the regular computer class. And then we also have another keyword that will be useful here, and I'll show you how to use both of them in just a second, is the super keyword. So the super keyword is what we use inside of the child class to call the parent class, and we have to use it at the beginning of the constructor for this to work. And you'll see that you're going to run into compiler errors if it doesn't. So those are the two main things as far as coding this up that you need to understand. But really, what you'll have to really grasp over time is kind of the concept of it rather than how you code up inheritance, because coding it up is not that difficult, but understanding how does one class have properties from another class and how do they change over time because of inheriting these properties, that's what's going to be kind of more difficult, I think, but you're going to get there. Just keep practicing and you'll get there. So another thing to note here that private variables in the parent class can't be accessed by child classes, but child classes can access protected variables in the parent class. And this is also something I think you learn more about in today's lesson. if you haven't already looked at it. So let me show you how this works with one example. So you might have a class called base, and this is the base class. And then you have a class called derived. Derived is the child class of the base class. How do we know this? Because derive extends base. So there's already a parent, the parent class is base, and parent extends, derived extends this parent class, therefore derived is the child class. So this is how you would extend a class, how you use that extends keyword. So if you want derived to have the properties of base, but you also want derived to have its own properties, then you use this extends keyword here. Okay, and what's interesting about this example is that in your parent class and in your base class, you have a method called show. You have a show inside of the base class, and you have a show inside of the derived class. But they do different things. And that's kind of what's really cool about inheritance, is that like you can pick up the properties of your parent class if you wanted to. So for example, if this method wasn't here, then derived could use this property of the base class without having to define it on its own. Or the child class can choose to override this this show method and create its own show method. So that's what's happening in this example. In this particular example, the child class is overriding the show method of the parent class. And you'll learn more about what overriding really means later on, but this is kind of like a preview into the future, I guess. So the question for this one was, what gets printed here? So by default in Java, if you're going to use a method that's implemented in both the base class and the child class, and the parent class and the child class, then first you want to make sure that first it's most likely going to execute what is in the child class. If the child class does not have an implementation for that method, then the parent class's example will be executed. So in this case, you're creating a object of the derived class, or an instance of the derived class, and then you're calling show on it. So in that case, it's going to print out derived show called. So I'm sure that's what actually gets printed out. Oh, we're getting all sorts of errors today. Okay, I'm not sure what's happening here. So you'll have to take my word for it that this does print out derived show called. Okay, here's another example of inheritance, okay? So you've got a parent class called animal, and then you've got a child class called cat. And cat basically extends animal, because we all know that cats are animals, but cats have their own properties. For example, cuteness level or has claws. So what you can do is you can define a cat class that extends the animal class, and then you can have it call the constructor for the animal class using super. And this is how you use super, by the way. You call super, and that calls this animal class's constructor. It constructs the animal class. But now you can also add your additional instance variables to the class, like cuteness level and has clause. So now the cat class is complete because it's used super to call the animal class's constructor, and then it has cuteness level and it has clause. So I hope that explained it a little bit better to you guys. So here's another thing. You see that these two are protected fields. So if in the parent class, if there are protected fields, that means the child class can access those variables. However, if these were private, they would not be able to access them. Cat would not be able to access animal fields. So yeah, that's what the protected keyword is there for. Any questions on that? I know that was a lot of information, especially since that's today's lesson, but you're going to be doing a lot of inheritance as we go forward. So better to just give you that overview. Okay, if there are no questions, let's go ahead and look at our first problem. Inheritance with the fish. So you're going to create a class called animal. An animal has only one method called sleep that returns the string I am sleeping. And then you're going to create a called fish. Wow. Create a class called fish. And then you're going to make sure that fish is a child class of animal. And then fish has one method called swim. And fish should print out I am swimming inside of swim. So you just need to make sure that you use extends correctly here so that the fish object can sleep and swim. Okay. We'll do 5 minutes for this one. And I'll try to figure out what's wrong with the playground. Okay, it looks like most people are done, so I'm going to go ahead and review this. So you want to create a public class animal. Yeah, public class animal, public string sleep, and return when I am sleeping. Okay, and then I want to create another class fish that extends sleep. So if fish extends sleep, fish is the child class and animal is the parent class. And then we want to do public swim, return, and okay. And that looks like what everybody else has. Yeah. And then what you can do to test this out, just to make sure fish can do everything you want fish to do, you can do fish, fish. And then do the system out, Gremlin, Nemo, swim. So Nemo can swim. So it has that property that's defined in the child class. But you also want to make sure that you have that property that is defined in the parent class. Nemo. Okay, so it can sleep and it can swim. Looks like it's working. Yeah. So one more problem on inheritance, and it's a computer problem. I'll quickly walk us through it since we've got 2 minutes left. I would highly recommend that you try this on your own. The solutions are at the end, so you can test it out and make sure that you have the correct answers. I'll just walk through the question. So you're going to create a parent class called computer. Computer's got a name and a battery life. And just create a constructor for computer. Then you're going to create a class called Dell computer, and it also has an instance variable called screen size, but it needs to inherit all of the properties of computer. So you need to call the constructor for computer from inside the constructor for Dell computer using the super keyword, and initialize the value of screen size afterwards. And then you're going to create a class called Apple Computer, and this should inherit the same instance variable as computer from up here. But it also has an iOS string type. So you need to use the super keyword again to call the constructor for computer and then initialize iOS. And then just be able to identify which one of these are parent classes and which one of these are child classes. Pretty straightforward, I think. It's very similar to the last problem, but now you're using super also as well as extends. But that is all for today. It's 7 o'clock. I won't hold you anymore. Thanks for stopping by, guys. Mhm.